this video explained truss problems using the Abacus software analysis. Area is given 300 millimeters square. Young modulus is 200 megapascals. Displacements for all the free degree of freedom, which is D1, D2, D3, D4 and D5s, are calculated by hand. And also reaction force at support, roller support 6 and pin support 7 and 8 is given here. The answers are given here. All internal forces are calculated. I like to verify these answers via SpaceGass softwares. So here it is starting of the SpaceGass software. So the value we got here is 2 meters, and then we will gonna make it at the middle. So let's do this ones. Draw members, hit 0, keep it vertical 2 meters, keep it horizontal 2 meters, middles, and then uncheck this, draw members, this ones, and now draw members again, and then just hit it in the middles and escape key to exit the command. Now we have single click, we have 2 kilonewtons, which is against the Y. So we have this one 2 kilonewtons here. So we have put this 2 kilonewton minus 2 because that is opposite to this positive Y directions. So that will give you 2. If you can't see the numbers, you can just put these diagram annotations and hit OK. Now once we done this ones, we can put the boundary conditions. This one is a pin, which is a pin here, and I can show you that pin is here. If you can't see the pin, you can put this one on. Double click roller supports, and this roller support is like horizontals, but we have vertical roller support, as you can see, that has a free in the Y displacement. So this free in the Y displacement. So the X is fixed, which is F, and the Y is free, so R is free. So let's keep it this ones, and that is the roller supports. We can define the members. We can just provide the cross sections, any cross sections that will do, but we're going to change the area by 300 millimeters square because that is given here. Area 300 millimeter. Young modulus is 200 megapascals, so that is still here. You don't need to change Poisson's ratio, any other details, just this young modulus, this one, and this area 300 that is given in our examples. And then just hit the analysis, linear static analysis, hit OK, and the analysis completed. Now we can compare it. We can just turn off the load. We need to show the reaction forces. So the reaction force is at 6, which is at roller support, positive 2. At 6, positive 2. At 7, negative 2. So that is 7, negative 2. So that is negative 2 at 7. And then we have 8, which is going up, and 8 is up is 2 kilonewtons. That is verified. So reaction force are verified. Now we can verify the displacement. So displacement, in the case of displacements, we have D1 0.07 positive, D1 0.07 positive. Perfect. Now we can compare D2, which is minus 0.08, D2 minus 0.08. Let me check. D2 is minus 0.32, D2 minus 0.32. D3 minus 0.08, which is here. D3 minus 0. Here minus 0.08, and then D4 minus 0.08, which is here. So D4 is this one, minus 0.08 Y, and this finally we have this minus 0.08, which is D5 minus 0.08. Minus sign meaning it is opposite to this arrow. We have verified reaction forces, we verify displacements. Now we can verify internal forces, which we can verify using axial forces, and you can verify those values 2.8, 2, 2, and these are zeros that are just shown here. I'm not reading it, but they are verified. Opposite signs, compression here negative, but in SpaceGass probably compression is positive, but that is the assumptions that the SpaceGass make. Thank you very much.